going to do more connecting position, velocity, and acceleration. Okay, so position. It can be thought of a certain place. The car is a certain distance. The particle is a certain movement from, with relation to time at a certain time. So usually it's a function written in terms of t. Velocity, we know that when we take the derivative d by dt, so we take the derivative of position in terms of time, we get velocity. And velocity as function is the change of the position function over time. So how is it changed from where did it start, where did it end, over how long did it take to get there? And then acceleration, we know that if we find the derivative in terms of time, we get dv dt, and that gives me acceleration. So acceleration function is a change of velocity function over time. And we can see here the double derivative, second derivative of position, s double prime, x double prime, or we can write it as v prime. Okay, so what does this mean? So motion. We can have two types of motion. We can have horizontal, so left and right. So we talk about a particle moving to the left, particle moving to the right, or we can have vertical, particle moving up or down. So left or right, up or down. So if a velocity is positive, and a velocity is a vector, which means it has a magnitude or a size and a direction, so negative or positive. So if it's positive, the object moves to the right in terms of horizontal, or up in terms of vertical. If the velocity is negative, then the object moves to the left, or it moves down. And then if the velocity is zero, the object is stopped, or at rest. Think about it as at rest. It is not moving. Speed is not the same as velocity. Velocity has both size and magnitude, a magnitude and direction, whereas speed does not indicate direction. So when we talk about give me the speed, we have to find the absolute value. So if I knew the velocity was negative 96 miles per hour, let's say, then if that was the velocity, then the speed would be positive 96 miles per hour. Okay. So as a result, the speed of an object must either be positive or zero, meaning the object is stopped. So when we talk about acceleration now, a horizontal acceleration, now if it's positive, horizontal, it accelerates to the right. Now notice this is not saying it's moving to the right, it's saying it accelerates to the right. We'll talk more about that when we distinguish how acceleration and velocity affects the speed of a particle, for example. If it's negative, then it accelerates to the left. If the velocity is not changing here, that's because the acceleration is zero. So it doesn't mean that the particle is not moving. It has a velocity, let's say a constant velocity of, in terms of a car, 80 miles per hour. If it's constant, then there's no acceleration because it's not increasing. Or there's a negative acceleration or decreasing. In terms of vertical, it's going to be up, accelerates upward, or accelerates downward. Okay, so important, when an object acceleration is zero, that does not mean the object is stopped, just that the velocity is not changing. So I've just talked about that. The thing about driving a car, there are two devices that change the velocity, namely the accelerator and the brake. One speeds it up, one slows it down, in conjunction of what the car is doing. Also, positive acceleration does not mean that you're moving to the right. Suppose you're walking to the right, velocity is positive, that's what makes me know that I'm walking to the right. And a strong wind starts to blow to the left, so let's think about this. Great wee person. If we're walking this way to the right, but the wind is pushing us this way, then we're going to slow down. This has got a lot to do with the signs of the velocity and acceleration. Okay, so here, example 1, a particle moves along the x-axis, the position function s of t equals t squared minus 4t plus 2. Let's go ahead and find the velocity and acceleration first off. So we know that the velocity is s prime of t, because it's the derivative of position, so that's 2t minus 4. Acceleration is the derivative of the velocity, or the second derivative of position, so that would just be 2. Now, at certain times t, we're going to look at what's happening with the particle and talk about its motion. However, we need to find some information about this. So, First thing we can fill out is the acceleration is 2. So no matter what's happening at whatever time, there's always an acceleration of 2. Okay, so take a minute and substitute in the values 0, 1, 2, 3, 4, 5. Come back and check your answer. So substitute into S of t. So if I put in the first one, put in 2. 2 squared minus 4 times 2 plus 2 gives me an answer of 2. Go ahead and pause the video and fill out the rest of these, then come back. If you want to check your first column, we get at time 0, 2, then it's negative 1, negative 2, negative 1, 2, 7. We're going to do the same for velocity, pause and come back. So we filled in the velocity column, negative 4, negative 2, 0, 2, 4, and 6. And then this one is easy, that's in green, absolute value of those. All right, so let's talk about what this means. So the position is where it is in relation to the x-axis, and we're going to draw it out on the next page. But let's talk about what this actually means for the particle, the motion of the particle. Okay, so because the velocity is negative, particle, let's change color here, particle is moving left. So the particle is moving left, okay? But the acceleration is pushing the particle right and be pushed right. So if it's moving to the left but being pushed right, it's slowing down. So really we're just concerned about, is it speeding up, is it slowing down, or potentially it's stopped. The second one is also, I'm going to just do a little copying marks here, moving to the left. The acceleration is again pushing right, so again it's slowing down. So both of these situations are the same. Here we've got a velocity of 0, so no matter what the acceleration is doing, the velocity being 0 means the particle has stopped. All right. This next one, now this time the particle is moving right because it's positive, and it's being pushed to the right. So in that case, it's speeding up, because not as it's moving to the right, it's getting helped along. And for this next one, the velocity is positive, so it's moving to the right, also being pushed right because of acceleration. And the last one, moving to the right because it's positive velocity, being pushed. So these are all the same. Okay, now in this next part, we're going to actually take these numbers and draw out what the particle has been doing. Okay, so let me see if I can squeeze both of these in here. It says mark the position of the particle at the given values of t from the table. Okay, so at time 0, the particle is at position 2. So when t equals 0, the particle is right here. And it is moving to the left because it's negative. So it's going to somehow go this way. At time 1, the particle is at negative 1, so all the way over to here. Well, that makes sense because it was supposed to be moving to the left. This is time 1. And then at time 2, the velocity is 0. So what that means is it's stopped somehow. It's not moved anywhere. So at time equals 2, it's at the position of negative 2. At time 3, it's back to negative 1, so somehow it's turned around. Come back, and that's based on the fact that at 0, we said it stopped, but this is going to the left because of the negative, and then going to the right. That's how we know that it's turned around. And that's at time 3. Mark this on here, time equals 3. At time 4, the position is at 2, so it's actually back to where it started. It's got all the way back over to here. This is time 4. And then at time 5, the position, remember that's that first column, oops, that first column which is 7, it's all the way over here at 7. So the particle started here at position 2, went to the left, stopped, turned around and came back at specific times. Okay, The table below will highlight the relationship between velocity and acceleration, oh, typo right there, with regard to how they affect the motion of the particle. Enter the phrases of speeding up, slowing down, or constant speed, or stopped. Okay, so it's based on, notice that it's based on the velocity and acceleration. So the velocity is positive, v is positive, or greater than 0. Let me just say it's positive. Oh, my pen's not working, sorry. And acceleration, a of t, is also positive. So that means it's speeding up. They're both the same because they're both going, so the velocity is positive going to the right, the acceleration is pushing it to the right, speeding up. We have a positive velocity, but a negative acceleration, which means it's going to the right, but the acceleration is pushing it to the left, so slowing down. Here the velocity is positive. The acceleration is 0, which means it's not trying to push it left or right, or speed it up or slow it down in any way, because it's not the same or different in terms of signs. So that means it's a constant speed. So the velocity, you're given an amount for velocity, and then the acceleration is 0, which means it's not changing. We should spell speed correctly. There we go. Velocity is negative, so it's going to the left. Acceleration is positive, so it's going to the left but being pushed to the right, so it's slowing down. Velocity is negative, acceleration is also negative, so it's going to the left and it's being pushed to the left, so it's speeding up. Velocity is negative, acceleration is not making any push onto it, it's not increasing it or slowing it down, therefore it's constant speed. To the left. Oops, going to speed again. This time velocity is 0, so there's no speed to it, which means it has to have stopped. So it doesn't actually matter what the acceleration is trying to do at all, because it can't do anything to an object that's not moving, because there's no velocity. Oh, that's another typo. Often seen question, or I guess an often seen question on the AP exam is with regard to when a particle is speeding up or slowing down, what we just talked about. So in order to decide whether the motion of a particle, we'll make a sign chart for velocity, one for acceleration, and a third, which is the product of the two, and it's thought of as motion. Or we can kind of combine them. Okay, so example 2, determine the time intervals where the particles travelling on a straight line defined by each of the given position functions and they're slowing up or slowing down. Or speeding, sorry, slowing down or speeding up. Slowing up or speeding down, nice. Okay, so we have the position. Let's find the velocity. Remember, we know that velocity is a derivative, so that's going to be 2t minus 6. Now, in order for us to find out what's happening or where there's important things happening, i.e. the velocity is changing from positive to negative, going left to right, which would tell us times when it's stopping, we have to find critical numbers, and critical numbers is where the derivative is equal to 0. So 2t minus 6 equals 0, 2t equals 6, t equals 3. So we have something important happening at 3. Let's also find the acceleration. We find the acceleration by taking the derivative of velocity or the second derivative of the position. So that would give me just 2. So there's a constant acceleration. Let's draw out a sign chart here, which we'll be doing more when we look more at graphs, but at this time, let's draw this out. We've got the point of 0, time. This is time. We have a value at 3 that's important. This is going to be talking about velocity, v of t. So we want to know what's happening here at either side of this value of 3. Is it positive or negative? So let's pick a number here. So let's pick 2. If I put 2 in here, 2 times 2 is 4, minus 6 makes it negative. That means the velocity is moving to the left. On the other side of 3, we can just pick 4. 2 times 4 is 8, minus 6 is positive, which means it's moving to the right. So now talking about the acceleration we know that is 2, so it's positive all the way throughout here, no matter where we're at, it's always positive. So what this means is we're looking at this first interval here from 0 to 3, it's moving to the left and it's being pushed to the right, so that means it's slowing down. So the particle, this is how we justify it. Particle is slowing down oops, spell the word down correctly, on, let's get the interval, it's going to be from 0 to 3. Since the sign, or actually since V of t and A of t have different signs. This is our justification. We have to explain when it's happening and why it's happening. So it's happening between 0 and 3. What's happening? It's slowing down. And why is it happening? It's because V and A have different signs. The particle is speeding up. This is the difference. So what's it doing? It's speeding up on 3 to, we have to assume infinity because we have no other critical values to look at. So forever, if you like. Since V of t and A of t have the same sign. Okay, both are positive. Now, it's not because they're both positive, it's because they're the same sign. Both, either both positive or both negative will make this work. All right, let's look at the second one. So in order for us to find this information, we need to get the velocity function, which is the derivative of the position function, so 3t squared minus 6t. We want to find the critical number that tells us if it's changing direction. So we've got v of t equal to 0. So we have 3t squared minus 6t equals to 0. Let's factor out a 3t. We're left with 3t is equal to t minus 2, which gives us at 0 and at 2. Okay, let's get the acceleration. Acceleration is the derivative of velocity, which is the second derivative of position, and that would be 6t minus 6. So the critical numbers for that is when the acceleration, you have to write this, equals to 0. You're telling the reader what you're doing. So 6t minus 6 equals 0, 6t equals 6, t equals 1. So there are three pieces of information that we have to put in here. Okay, let's draw out a chart. So for velocity, let's do that. 0 and 2. And I'm going to be thinking about 1, just because that's going to be in acceleration. So this is the velocity. Let's draw out an acceleration 1. Got 1 to put 0 in, because it's not going to be a time less than 0. That's crazy talk. Okay, so if I put in some values here for between 0 and 1, throw it in here, so let's say a half, that's going to give me a positive, a half minus 2 is negative, this is going to be negative. Let's do the other side. Why am I not just doing 0 to 2? Because 1 is an issue right here. If I put in 1.5, I'm still going to get 1.5 minus 2, so it's still going to be negative. So basically all across here it's negative. I just have to be aware of 1 because something's happening there because of acceleration. So left, left. Let's look at the other side of 2. If I put in 3, let's say, I should get a positive answer. And that's moving right. Okay. Let's look at acceleration. We're looking at the acceleration function. So 1.5, throw in 2 as well. So if I say 1.5, would be over here, then put in 1.5 times 6 minus 6 is going to give me positive. If I put less than, so a half, that would be 3 minus 6, that's going to be negative. Oops. So that means I am pushing left, pushing right. Okay, so final answers here. The particle is, I'm seeing same sign, different sign. Oh, I forgot to find this one. So greater than 2, so 3, that's going to be positive as well. So same sign. So same sign, different sign. So I'm going to have both situations. So the particle is, let's do speeding up first. Doesn't matter as long as you justify and have the right intervals. So it's speeding up, which means the same sign from 0 to 1 and from 2 to infinity. Since v of t and a of t have the same sign. Doesn't matter that it's negative. They have to have the same sign because they're moving left and pushing left, being pushed left, and moving right and being pushed right. And then the particle, oops, can't spell particle, is slowing down on, oops, that would be 1 to 2 because you have different signs, since b of t and a of t have different signs, and that's all you have to do to justify it. Okay. All right. We're going to do 3 and 4. So the graph below models a bug, the velocity of a bug on the interval from 0 to 13. So this is the velocity function. Find v of 3 and v of 11. It's easy enough. V of 3, I just have to look at the graph because it's the velocity. What's it at 3? It looks like it's at 6. And then v of 11, I look down here, and that looks like it's at negative 2. Just check the graph. Yep, right here. Okay. It says find acceleration, so a of 1, a of 5, a of 9. So that means this is v prime of 1. A of 1 equals v prime of 1, which means the slope, the rate of change. So looking at 1, this slope looks like it goes up 2 over 1. So that's going to be 2. A of 5 is v prime of 5, so the slope at 5, look at 5, that slope is 0. And a of 9 is v prime of 9, which is 9 is at, what's this going to be? Let's solve the whole thing. 1, 2, looks like it's negative 3 over 1, so negative 3 over 1, or just negative 3. Okay, part C. At what time does the bug turn around? Give a reason for your answer. So we know back here when we did this part, at negative 2, the bug turned around, or the particle rather turned around because it moved from going left to going right. How do I know that? Because the velocity was negative to being the velocity being positive. Okay, so if we look at a graph, and we get it because of the values at those times. So in terms of looking at a graph, velocities being positive is going to be anything above the axes. Velocities being negative is going to be anything below. So this is velocity being negative, velocity being positive, as we're looking for. So a change from positive to negative velocities happens at 9. So the bug turned around at t equals 9 since the velocity changed signs from positive to negative. Don't remember to forget to say at t equals 9. Now, does it matter that it's specifically from positive to negative? No, because that just means it goes right and then left. If it was from negative to positive, left then right. So just where it crosses that axis. Why? Because and v of t equals 0. So the derivative is 0 at that value of the position. And what interval does the bug have a negative acceleration? Right, so negative acceleration, so let's think about this. Acceleration is the derivative of velocity. If a of t is less than 0, that means that the derivative is 0, which means the slopes are 0, which means they're going down to the right. Where does that happen? If I look at the graph, the slopes are 0, or the function is, you can think about it, the function or the graph is decreasing along here. These are all negative slopes right here. Positive slopes here, 0 slope, positive slopes, so this is all negative slopes right here. So that's between 7 and 10. So the bug has a negative acceleration on 7 to 10 since v prime is less than 0. I guess I could just put v prime is less than 0. Right, last example. Particles moving along the horizontal line with position function, S of t. Do analysis of the particle's direction, acceleration, motion, speeding up or slowing down, and position. Okay, so same as before. So let's get the velocity. It's going to be 3t squared minus 18t plus 24. V of t equals 0. That's how we find those numbers where things will change from positive to negative, critical numbers. It's going to be 3t squared minus 18t plus 24 equals 0. We can factor out a 3. So everything by 3. Oh, why have I got a 3 in here? So I was thinking about a 3. And then factor. So it's going to be 4 and 2. And they're both negative to make positive 8 and negative 6. So t equals 2 and t equals 4. Let's find the critical numbers for acceleration. A of t is the derivative of the velocity. Let's find that derivative. That's going to give me 6t minus 18. We're going to set a of t equal to 0. So I can take it as 6, and I'm going to have t minus 3 equals 0, t equals 0. I could just move it over and divide it by 6. Either is fine. So t is 3. Okay. So critical values we care about are at 2, 4, and 3. Okay, so let's draw out the velocity. That's going to be greater than 0, so not equal to 0. We have 2 and 4. And I have to think about 3 as well somehow. Okay, so this is v of t. We're putting in values between 0 and 2, 2 and 3, etc., etc. When we do this, this is going to be positive. This is negative, and this is positive. So it's moving to the right, to the left, and to the right again. Let's do acceleration. So we have between 0 and 3. We might want to look at 2 and 4. So the signs, if I put this into this function that we have here, all negative, then actually all positive. Okay. So with in mind, we're going to look at specific intervals. So we're going to look between 0 and 2. We're going to look between 2 and 3. Let's see if we can get this to work. 3 and 4. And then 4 and infinity. And highlight places where they're the same or different. Okay, so the particle is sort of speeding up. Speeding up on when it has the same sign. So it has the same sign, these are all negatives. So between 2 and 3, because it's negative for the velocity, negative acceleration, and 4 to infinity. Since v of t and a of t have the same sign. Same sign, speeding up. All right, and then let's do slowing down. The particle is slowing down on, let's see, different signs, so negative and positive, so from 0 to 2. And 2 to 3. So really between 0 and 3. Well, actually it stops. So between 0 and 2 and 2 and 3. Because at 2, the velocity is 0. Since A of t and v of t have the same sign, have different signs, sorry. A of t and v of t have different signs. Okay. All right, so it's simple in concept. It's just being able to identify the numbers and doing the derivatives and stuff and interpreting the meaning. We're going to talk about this. Oh dear, computer's not having fun today. Example 5 in class. So if you want to go ahead and try a couple of these and then compare answers, we can do that. All right, see you then.